Forensic characterizations of bloodstains. 3 things you have to determine at the scene when you think you found blood. You need to determine, well, is it blood or did somebody's Frank's Red Hot explode? If it is blood, did it come from a human or was somebody butchering a chicken in their living room? And finally, is it so-and-so's blood? Is it the suspect's blood? Is it the victim's blood? Is it the person's blood that you think it actually came from? 3 jobs of blood characterization. There's a variety of different kinds of tests that you can use to rule in the possibility of that being blood or being human blood or somebody's blood, and other tests that you might prefer to use to rule out that fact. Color tests are pretty straightforward. They change color when introduced. To blood. Say from clear to pink, for example. Luminescent tests glow in the presence of blood. Microcrystalline tests cause blood to crystallize. Precipitin tests look for agglutination or like little clots of things that you refer to as precipitate. Looks for precipitate. And gel diffusion, which exploits molecular movement through a porous gel. So you put molecules into different wells in a gel that has pores, little holes through it, and as that stuff in each of the wells diffuses into the gel, they may or may not become attracted to each other, and you can see that because the gel is clear. So these different kinds of tests will be used under different circumstances depending on what information you have available to you and what information you need to rule in or rule out to try to identify potential suspects or to identify blood from a victim. The Kastle-Meyer blood test is a very, very simple test where you use stuff that is already in blood and then react it with something that'll change color. So I mentioned before, blood has hemoglobin. That's that molecule in blood cells that makes it red. It's what attaches on to oxygen and delivers oxygen to your cells. And it also has an enzyme called peroxidase, and that helps break down some stuff inside the cell. What you'll do is you will swab up a blood stain, a little bit of blood off of a blood stain, and you'll apply this mixture of phenolphthalein and hydrogen peroxide. It looks fairly clear inside the container, but when you apply it to blood, it'll turn this beautiful, bright, bright pink color. There are circumstances where you could apply it and it'll turn up positive, even though it's not blood. Those are called false positives. That's if you applied it to something that's made out of potato products or horseradish. I mean, frankly, you're not really mistaking those things for blood anyway, so in reality, in practice, you don't have to worry so much about false positives with it. This is a determiner for, is it blood? Is it even blood in the first place? It can't tell you whether or not it's human blood. It can only tell you that it's blood from a creature that carries hemoglobin, which is like all mammals and a bunch of different reptiles, and like there's some fish and stuff that doesn't use hemoglobin in its blood, but anything that you might have around the house that's a creature is going to have hemoglobin. So it could be any creature's blood. And it certainly can't tell you then if it's from an individual. It'll simply tell you, is this hot sauce or is it blood? Hemostix is another way that you can identify if something is blood. It's a blood determinant test. And this is a simple urine dipstick test that you might see at a doctor's office. It has a reagent mixed in or impregnated into the paper already. You moisten it, you rub it onto blood, you let it develop, and then you compare it to the chart on the container of hemosticks. The darker the green, the more concentrated the blood is. Luminescent tests, again, glow. They're glowing tests. And luminol is a kind of a spray application. What you do is you have a field that you think has blood on it. You spray it all over this field. You shut off the lights. It's luminol mixed with hydrogen peroxide. The hydrogen peroxide will react with the iron in the blood. That'll release oxygen. The oxygen activates luminol and it glows. It glows this faint blue in the presence of oxygen from bloodstains. When you shut off the lights because it requires total darkness to see, you will see any and all blood that was on that field basically forever. I mean, it's extremely, extremely sensitive down to very, very small quantities. Hemoglobin is a protein. Iron is an element. Even if you use bleach, if you scrub, these things are very, very hard to get up totally. So on one hand, it's great. It'll work on fresh blood. It'll work on super old blood. It's extremely sensitive. It doesn't interfere with DNA testing. That's a huge plus. And it's a very, very good blood determiner. It doesn't really come up with a false positive for many other things. Unfortunately, since it will also illuminate any old blood, if you're doing this at some place where you might be more likely to have some sort of a blood droplet spill, like around the toilet or perhaps in sheets, around a first aid kit, you might come up with a lot of blood that doesn't have anything to do with the scene of the crime. Additionally, feces, urine, and vomit can all have, and frequently do have, traces of blood in them. If the person has pets, and the pets have ever vomited on a rug, or peed on a rug, or pooped inside, or whatever, there's a really good chance that you're going to have pet blood embedded into your garments. Even if you've cleaned it up, you can't smell it anymore, there's still going to be some iron fragments left behind after you've cleaned. They will also come up positive. Somebody with a bunch of cats, if you spray this all over their rugs, it's going to look like somebody was bludgeoned to death on their rug. That might not be actually the case. Microcrystalline tests are where you add chemicals to blood. So you get a droplet of fresh liquid blood and you add chemicals to it to create crystals from the hemoglobin. Again, this is a blood determinant. It is not specific to human blood, but it can help determine if hemoglobin is mixed into a substance. So if you have a sample of blood that is not pure blood, perhaps it's mixed into mud or something, this can help precipitate out into these crystals hemoglobin. You can make the blood stand out from the rest of that solution by doing this. There's a bunch of different chemicals that are used to do these microcrystalline tests. They're not terribly sensitive and they're not terribly easy to do, so they're not relied upon very much, but they can be essential if you have mixed blood. A precipitin test is also a blood determinant. But even better, it's a human determinant. This will work if it's human blood specifically. So if you did this test with hot sauce, it wouldn't work. It would be an expensive waste of the test, but it wouldn't work. It would be an accurate negative. And if you used cat's blood or chicken blood or whatever, it also won't work. You can determine whether or not this blood is human or not. What you'll do is you'll mix blood with anti-sera. So you'll have a test tube with antibodies. That's anti-sera with antibody. Anti-sera is a liquid with antibodies suspended in it. Remember, antibodies are specific. So these antibodies have already been engineered to agglutinate with certain kinds of human blood. You apply the blood to the tube also. You basically just pour it over gently. And the antibodies will agglutinate with the antigens and create this cloudy kind of a layer in between. It's usually not this obvious. This specific test tube was created to give an illustration of it. It's usually, red up top and red down below. And this is sort of a faded orangey kind of a band in the middle, but you should see a pretty appreciably large band in the middle. If you have that band, then the antibodies were able to agglutinate and you have a match. If you have no agglutination, if you do not have that band, then that serum is either not blood or it's not human blood. Gel diffusion is where you're going to apply blood into 2 wells in a porous gel medium. When you let that sit, the liquids will diffuse through the gel equally in all directions. This doesn't really illustrate that point, but it'll diffuse equally in all directions. And where they have diffused in the direction close to one another, if the antibodies and the antigens are a match, then you'll have agglutination in the middle. You'll have this precipitation line down the middle. They'll move towards one another via diffusion in the middle, and then they'll agglutinate. This and the precipitin test are both very, 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 very sensitive. The gel diffusion in particular is so sensitive and works so well with old blood. The precipitin test requires fresh blood. The gel diffusion test is so good it can work for ancient blood. They've used it to help characterize the blood of mummies. Of course, the older it is and the less you have, the less this works. But it can be done. It's certainly not impossible. It can also work very well for diluted blood. If you only have a little bit of blood, as long as you can get it to stretched out enough to fill that well, you could potentially come up with a match. So we've already had a couple of tests that are blood determinants. And we've had a couple that are human determinants. Can tell you whether or not something is blood, and if it is, whether or not it comes from a human. Now, what tests do we have that determine whether or not it is so-and-so's blood? Well, what we used to do is just rely on ABO blood typing. That's that blood typing we were talking about earlier, where you take somebody's blood and you put it in wells and you apply antibodies and you wait to see if there's agglutination or not. This can help confirm whether or not a person's blood type matches what you think it should be or what you think the victim's blood or the suspect's blood is. But lots of people have that same blood type. It is not at all a precise test. Just because you find B negative blood at the scene does not mean I killed somebody. It means that somebody with the same blood type as I have, which are millions of people, probably was at least present at the scene. It can rule out people. If I have B positive blood and you find B negative blood at the scene, then that blood's definitely not mine. If I have B negative blood and you find B negative blood at the scene, it could be mine, but it could just as likely not be. That's by no means a nail in my coffin. So it's highly imprecise. It can help rule people out quite definitively, but not rule people in very well. We used to rely on that all the time because we didn't have anything better. Now we have DNA testing. As it's become quick and inexpensive relative to what it used to be, we can do it very, very easily, and it's available in most labs. DNA characterization is the preferred method and really the only convincing method of true individual biological identification.